Okay, I think it's time now. Let's start the webinar today. So good morning and good evening or good afternoon, everyone. So my name is Jeremy Hu. It's a great pleasure to meet you again here. And today I'm going to present the webinar together with my colleague Taylor. And yeah, Taylor, maybe you can say hi to my clients. Yeah.
Hello, everyone. This is Taylor from IoT Technologies support team. I'm very glad today to be here to share our solution to you.
Thank you, Taylor. So as InHand Networks, we have been focused on the IoT industry for more than 22 years. And so we would like to share some of our experience in this area. And if there is anything that can help to inspire you somehow and what we have done is worthy. So today our topic is remotely manage your machines with IoT edge technologies. We would like to start our presentation from these 4 aspects today. And firstly, we would introduce about remote management technology with the IoT. And second, I would like to introduce some success stories about the remote management and preventive maintenance from our clients. And third one, Taylor would help to make a demonstration about how to configure the data acquisition in minutes with our device. And in the end, I would like to introduce a little bit more about our company. So let's start from the first part, remote management with the IoT technologies. Well, now the machines has entered the industry automation market area. So industry automation is used for control of systems and information technology to totally replace the human beings. And this is a new trend in nowadays. And you can see from the research that now in this year, the market is around 231 billion, and it continued to go at a very high rates, around 8.6% every year. And in 2030, it will be more than 400 billion. So the market goes very fast. And the main factor I have to see that drives this market is the real-time data analysis and the increased maintenance of the development of the technology, or more specifically, the remote technology to drive these goals. And so here you can see in the factories, I guess there must be tons of machines, although they wouldn't like the human beings to get sick easily. But once there is any problem, you have to admit that there can be a chance for them to break down. If these things happen, then it will greatly influence the manufacturing capacity of the whole factory. And so how to monitoring this device in real time to know what their status and what would be trained for this equipment is very crucial for the factory. And besides, once there is any problem that happens, I guess you would like to bring back to normal. For example, you would like to remote control the equipment or carry out some upgrade or programming of the equipment to bring it back to normal. And so that you can achieve a lot of benefits. You can reduce the downtime time, and you can increase productivity, improve the product quality. Well, that's all the benefits brought by the remote management. And so that's the reason why we want to introduce that. And how do we deploy the remote management? Here, I have to say we want to introduce a very core technology, the IoT Internet of Things technology. So in this, wait one moment. I think we missed the picture. Yeah, this one correct. So here you can see this is the whole diagram of the 4 layers of the IoT technologies for remote management. So in the first layer, you need to acquire the data, and it is the sensor and the control layer. The second layer is network layer. Its main purpose is for data pre-processing and transfer. And then the data will be further transferred to the platform layer, SID layer, where you can build your own application like the equipment predictive maintenance, equipment monitoring, equipment control, so that to help you to achieve the remote management. Well, this solution looks a little bit abstract, and next slide, I will show you a more concrete slide of our solutions. Yeah. So in the factory, so every minute the machines will generate tons of data, the pressure, the temperature, speed, the humidity, all this data is well collected by the PLC or the controller or the sensor, And then they will be packaged to different protocols like then Ethernet IP or Modbus or the ISO and TCP, all these different formats, and then further transferred to the networking device. Here, this direction we call the southbound interface. And then after data arriving at the networking device, there are two actions for them. First, you can carry out you need to recognize this data at these different formats and depackage them, and we code them to different standard formats like the MQTT or the HTTPS. And here you can regard the gateway as a super talented translator. It can translate different languages to our standard language like English. So yeah, and second, the action is that since there are quite a lot of data, actually there are a lot of unnecessary or repetitive, you want to filter them or pre-calculate them, then you can do the edge computing in the gateway side for you to release the burden for the cloud platform. And then the data will be further transferred to the cloud platforms for your deep analysis, and then you can, for example, you can check the status, whether it works right for your machines. And this direction we call the northbound interface. So from the data acquisition until the cloud platform, this is the whole picture of the solutions. And normally the data acquisition is not a big problem. And here we will mainly focus on the data transfer or the pre-processing process. There might be a lot of problems, but today we want to introduce the 4 common problems that we might meet. Okay, the first one, as we mentioned, is the data acquisition. So here we take a Schneider electricity PLC example, and it will generate different data, temperature, pressure, humidity. Then the data will be coded in a Modbus RTU protocol, this format, and you can see it here. And the problem to recognize this protocol isn't well, not a big deal for the device, but imagine that in the factory you have tons of thousands of machines from different brands, different suppliers, and each has their own protocols. Like for Rockwell automation device, will use the Ethernet IP, and for the Mitsubishi, it will use this another protocol, or even you can use your own private protocol. So if you consider that each one with a device will be a waste of time, money, and also a waste of efficiency. So considering this, we actually developed our own device supervisor agent, this one at our in-gateway. So it can help translate different protocol to the one you needed, and then transfer to the cloud platform. So that's how we solve this one issue. And later, Taylor will show you how we do this, use the device supervisor of the in-gateway. The second issue is about device connection. I have to say that in the factory, thousands of machines, they might be connected by Wi-Fi or I/O or Ethernet or series. If each one need a special device to connect it, then it will also be no efficiency and waste of money. So considering this issue, we integrate all the ports into the devices. And so by doing that, you can use one device to connect lots of machines in your factory. So in the right hand, we show you a picture how we install this device in the factory. In the cabinet, you can see it has very compact size, and it's used Wi-Fi to connect one device, and also our Ethernet cable to connect another device. And the third issue is about the data handling. So in I've said that in factory there are lots of machines. Due to real-time monitoring, it will generate tons of data. Here I take the temperature data as an example. For example, they will generate a lot of temperature data, but I only need the data below 10 degrees and regard it as an abnormal situation. And so I need to filter this data. And here you can see that by edge computing, I can simply remain only in the data I needed. And if I want to, I don't like the way I want to transform it to another unit like the Fahrenheit, and then I can set some simple rules and the networking device and to transfer it to the Fahrenheit, and then transfer the need data to the cloud platform, to the application. Then I can correlate this data with abnormal situation. For example, like if there is a 6 degree, I know at that point there might be something wrong with my machine. I need to check what happens for my machine. Yeah. So that's how it works for the data handling. And last one is data safety. So I guess you don't want your data to be to leak it to other people or to get unauthorized access for others. So here we have different safety strategies for the devices. The Open VPN, it is the encryption technology to protect data transmission, and the firewalls to protect network security, and multi-layer user authorization to protect the system against external attacks. So by this strategy, you can ensure that data safety. Well, that's how we solve these different problems by our device. Then I would like to explain a little bit about the third layer and fourth layer, the cloud platform and the application. So for the cloud platform, now there are two types, the private cloud and the public cloud, like it's Azure or AWS. So, and this cloud platform, you can build your own application, and then you can achieve that the equipment monitoring or alarm management, all this function as you want it. One point I want to mention that our device is certificated by the Azure and AWS, so it can be no issue to send data or connect to this platform. Yeah. Besides that, we also developed two remote management applications for our clients. One is named the InConnect, another is Device Manager. So for InConnect, you can control get the remote access to the end device like POC or the PC directly. You can carry out the program this POC directly remotely. And for the device manager, it's mainly for our gateway management. For example, you can check how much data it has used and where it's located, what's the status of the gateway. Yeah. So very convenient for you to use. So that's a brief introduction of the remote management with IoT technology. So next, I will show you some cases about how we do it. And the first one is about the air compressor. So it is a world leading vendor of the air compressor. They are seeking a remote management solution for their distributed machines all over the world in the factory. And due to some confidential issue, I cannot say his name, but it's okay, yeah. And here they face three big problems. One is the scale and how to gather data from thousands of remote installed air compressors in an efficient way. The second one is legacy. There are different types of air compressor and they have different protocols, and that's one big problem. And the third one is compatibility. The air compressor, now they have their own DC as control system, and how to acquire this data without disturbing this existing control system is also a problem. So by understanding the issues from the client, we found this solution for the client, which is our IT502 for the client. And here you can see that the controller and electricity meters and sensor from the air compressor, the data generated from these devices can be connected to our IT502 through the Ethernet or serial ports, and using the different protocols like Modbus or OPC UA. And then the data will be pre-processed in the gateway. For example, here they transfer the unit to another unit, and the data can then be further transferred to the cloud platform, the bus SaaS, business SaaS, and through the 4G similar network. And besides that, the client also want to remain some data locally. So we also use the Ethernet serial port to connect to their local platform and using the Modbus and OPC UA protocol. And in this solution, the client also adopted our two applications. One is the device manager and one is InConnect to control the controller, to remote access the controller and also control our gateway. And then by deploying this solution, what we have brought to the client, the first that they can carry out the real-time monitoring of the compressor in real status. So timely responding when compressor parts need to be replaced. And so this can actually enhance their secondary sales for the components. And second is that they now can notify the responsible person in real time when the air compressor failure happens, and to improve the efficiency and yeah. And third one is they accumulate a lot of data for the air compressor and then optimize their design and improve the manufacturing process. So generally speaking, we greatly increase the class term certification and loyalty in this case. And here I show you some outstanding features of the product IG502 used in this case. In right hand, you can see it has 4G and LTE Cat 4, and it supports different industry protocols and support to the AWS and Azure, and abundant interface and part of edge computing and Python programs, so very good for the IoT technology usage. And one point I want to mention that also it's a honorable nomination of the Engineering Choice Awards in last year. Yeah. And here, actually, the client at the beginning want to choose another solution of VPN plus SCADA. So why didn't they finally choose our IG502 Gateway plus the cloud solution? Here are some main reasons I listed. The first one is that the cloud solution actually has no limitation of the application. You can deploy any limited applications as you wish, but then this cannot be done. That cannot be done in the SCADA system. And also, since our gateway can carry out edge computing, you can pre-process the data and edge, which can release great pressure for the cloud and reduce the data traffic. And all these good benefits push the clients to choose our IG502 Gateway plus the cloud solution. And the second case about the remote management of textile machines, also from our European manufacturer. They have faced the same problems like its first client, but one more point is that they want to run their own software and our device to pre-process the data. So here you can see it used the IoT Edge deployed and our IT902 this device, and for the better the edge computing ability. And then they have developed 4 Dockers to run on our IT902 and to easily program for data acquisition. And data from the textile machines can be transferred through the Ethernet to the IT902 and then further transferred to the Microsoft Azure cloud platform. Yeah, also they adapt the InConnect and device manager for this solution to manage the device and also the gateway. Well, in this solution, they adapted the IT902. This one, it has an even more open platform. It can support the Python, Docker, and also the Azure IoT Edge and AWS Greengrass. Yeah. And the third one is the case for the generator management. And it's actually very similar to the previous 2 cases. But one point I want to mention here is that the client asked to support the latest version of Azure IoT Edge, which can only be supported by Linux distribution version. And this of the feature of our edge computer 900, this device. And so the data now can be collected from controllers to the Modbus to the edge computer and then transfer this to the 5G cellular network to the business SaaS platform. Yeah. Well, that's the EC900 device, and I want to say it's just even more open than the previous two products. And you can see it used the Linux Debian OS, and it has a very strong performance because it used the Rockchip RK3568, and yeah, general better performance than previous two products. Yeah. Okay, that's the case for the IoT technology and these cases. And next, I want to let Taylor to control the screen and to make a demonstration of our IoT 902.
Okay, thank you, Jeremy. Okay, so in this part, I will show you how to configure on our IG web page to collect data, process data, and upload data to cloud using our device supervisor. I will take an IG 902 and a temperature humidity transmitter as example. Okay, please see this photo. The transmitter now is already connected to my IG 902 through serial port in the lab. Okay, let's go to device manager. Okay, as you can see, device manager can help you to centralize manage the in-hand devices. There are some routers and some gateways under my account. Okay, let's click IG 902 and click Web Management button. Now let's remotely access to the IG 902. Okay, log in and go to edge computing menu. As you can see, edge computing includes passive computing, software computing, cloud edge computing, and our device supervisor. Let's focus on device supervisor. Actually, device supervisor is a built-in passive application provided by InHand. It can help users to collect data, process data, and upload data to cloud. Okay, let's go to device supervisor page. Before adding a controller in this list, please make all the parameter specifications of your controller clear, like the serial port tab, the baud rate, and other parameters. So first step, we go to parameter settings. Now I will set a parameter of RS485 serial port according to my temperature transmitter. I need to set it like this and hit submit. And next step, we go back to Mayor Monitor page to add the controller. Click the Add button. We give it a name, for example, demo, and select the protocol of this controller. As you can see, IG products support most of the common used industrial protocols. And now I will set Modbus RTU for my temperature controller. Okay, and set the slave endpoint port interval and hit confirm. So now this temperature controller is successfully added here. And next step, we go to add measure point of this controller. For this demo, the measure points are temperature and humidity. So let's add them one by one. Let's add the temperature measure point first. Okay, and set a register address supporting the specifications, and also the data type in read-only, and give it a unit. This one. Okay, and the default group. And I need to zoom out the row value of this controller because the row value of this controller is 10 times as many as the actual one. So I need to set it $1. Okay, hit confirm. Now the temperature measure point is successfully added to the measure point list. And let's wait for a few seconds wait for the temperature measurement point logging. Okay, now you can see the indicator becomes green from green. That means the communication is normal and the value is in reading, and you can see the value here. And also let's add the humidity measurement point in the same way. Data type word, give it a unit, and also zoom out it. Okay, hit confirm. Okay, now both the two measurement points are added successfully. If you want to monitor the Fahrenheit value, we can directly configure a simple data calculation according to the computation formula. Let's edit it and use the formula to configure it. Offset 32 and change the unit to this one. Okay, hit confirm and wait for a few seconds. It will be the Fahrenheit value. Okay, now you can see here. Okay, so now you can monitor the temperature and the humidity value in local.
Great. So yeah, what if I want to monitor this data in cloud platform? Can you also show us?
Of course, device provider can also help you to parse the raw data from different protocols to the protocol you want. For example, it can convert the Modbus RTU data to MQTT data and upload the data in JSON format to the cloud. Let me take a standard MQTT platform for an example. As you can see here, I will take a public MQTT platform of EMQX for this demo. Let's add to our IG902 page. Go to cloud page and enable the cloud and set the server address and give it a unique client ID. Okay, and hit submit. And then we go to EMQX dashboard, click the connect. And after the configuration take effect, you can see the cloud status here. Okay, the connection is successful. So next step, we need to go to create a new publishment under the message management to send the message to cloud. Click add and give it a name, for example, demo, and the default group and label, and give it a topic, also demo, and the QoS1 entry function main, and in the quick function, you can enter your own passing code according to your needs. And for this demo, I will take the default one. It's confirmed. Okay, now the publishment is created successfully. And now we need to go to MQX dashboard to create a subscription to receive the message from IG. Okay, let's configure topic as the demo and also the QoS1 and click submit. Okay, and after the configuration take effect, you can check here, received message. The message is successfully uploaded to cloud. It's very simple, right, Jeremy?
Yeah, yeah.
Okay, and in addition to convert to MQTT data, IG can help you to convert protocols from these protocols: Modbus TCP, IEC 104, OPC-UA, and Modbus RTU. I think it would be very helpful if users want to convert different protocols from their different devices to the same one.
Yeah. Okay, so thank you, Taylor, for the presentation. And in the last part, I'm going to introduce a little bit about who we are. For those who are not familiar with us, so as In-Hand Networks, we were founded in 2001 as a pioneer of IoT. After 22 years development, we have served the global different clients like the State Grid, the GE, the ABB, the Siemens. And our new factory construction was completed in 2019. And then we were public the company in Shanghai Stock Market. Yeah, so a very brief introduction, history of our company. And now our global center is in Beijing, China, and our overseas center is in US, Tunis. And we also have the German office and Canada office to support our different areas clients. Now we have more than 400 employees, among which 1/3 are R&D people, so very strong technology support team. And here is a picture of a factory. Now it has 7 production lines with a very high level of flexibility. Every day can produce 3,000 units products and have very large area. And here are some certifications about a company, and you can no worries about the quality of our site. And that's all for today's webinar. And then the last part is the Q&A. If you have any question, please feel free to raise, and our technical engineers are online also to support you. Or if you have any questions, you can write message to me or Taylor, and we are always online to help you. Yeah. Okay, I will stop the sharing. Let's wait 1 minute for the client's questions. If not, so we will end the webinar today.
Please feel free to ask us.
Yeah, I hope that our solution can somehow help you and also inspire you for the remote management for your devices. And that's our purpose for today's webinar. Yeah. Okay, I think there is someone. Okay. Let me stop the sharing. Okay, so that's the today's webinar, because we almost run out of time.
Can we take actions on sensors based on?
So yeah, can the gateway take actions and the sensor based on input received from the sensor? Louis is help to answer this question. And, yeah. Okay, sorry.
Okay, I think I can answer this question. Can the gateway take actions on the sensors based on input it received from sensors? If I understand correctly, this question is asking if our IG product can send the how to say, to manage the sensors, to send the changing of the value. For example, if I want to remotely change the current value, temperature value to 20, from 20 to 10, I can send a path stream to control it, to change the value.
The answer is yes, yeah, it's 40. Yeah.
From cloud or from IG.
Correct. Okay, I think the listeners are quite interested about our products, and we have left our contact message in and slides, and later we will share this slide to you. And if you have further questions, we are always online to support you. And since today we are almost run out of time, we will stop here. And thank you very much for your joining, and have a nice day. Yeah, that's all. Thank you. Bye.